Okay, this is a super, as quickly as possible, how to do piecewise functions. Starting with, you have a piecewise function and you need to plug numbers in. So this first function, f of x equals 5x minus 1 and f of x equals x minus 9. You use the first function, 5x minus 1, if your x values are less than negative 3. If your x values are negative 3 or larger, you use the second function, x minus 9. So these all should actually say f, not h. So f of negative 3. We cannot use the top function because x has to be less than negative 3, not equal to negative 3. So because we want to use negative 3, we have to use our bottom function, x minus 9. So we would take negative 3 and plug it into that second equation, second function. And negative 3 minus 9 is negative 12. Oops, it'd be nice if I put an equal sign in there. For number 2, we want to do f of 5. 5 is larger than negative 3, so we would use the second function. So f of 5, we would use the function x minus 9, and you'd plug 5 into that. F of 5 would be negative 4. So that's the basics of how to use a piecewise function. Depending on your x value, pick the correct piece. You have to be wise about which piece you use. Piecewise. Haha, not funny. Okay. Moving on. Turn the page and let's look at some graphs. We're actually going to start with graph 6. There are 2 ways to do graphing piecewise functions. I prefer graphing the first function in pencil and then looking at what the x values need to be and filling that in with a colored pen and then erasing the chunk of the line that you don't need. But I'm finding that some students prefer using table of values instead, that seems to make more sense. So we're going to do number 6 using a table of values. I'm going to do the first function in purple. So I'm going to make myself a table of values, x and 3x minus 2. We're going to plug our x values into 3x minus 2. Based on that little inequality, what x values can we use? We can use 4, and then 3, 2, and so on. Is 4 included in one of those x values? Yes. So I want you next to 4, put a closed dot, and then this pattern would continue. It'd be 4, 3, 2, and it'd continue in that direction. Okay, let's plug 4 in. 3 times 4 is 12. 12 minus 2 is 10. 3 times 3 is 9. 9 minus 2 is 7. And 3 times 2 is 6. 6 minus 2 is 4. Plot those 3 points on your graph. 4, 10. 3, 7. 2. Okay, now because it says x is less than or equal to 4, that's a closed dot at 4, and notice the way that I drew this arrow through these next 2 points. So from the point 4, 10, we're going to connect to the other 2 points and then continue that in that same direction on the graph. So the piece 3x minus 2 for x values smaller than or equal to 4, on this line, all x values that are 4 or smaller are contained within that line. Now let's choose another color and do our second piece. So, table of values with negative 2x plus 6. All right, now I am going to use an x value of 4, but are we really supposed to use an x value of 4? No, it's going to be the ending point, but there's going to be an open circle on that. So draw an open circle next to 4. what other x values can we use? 5, 6, and so on. So we can't actually use 4, but 4 is going to kind of be the ending point with an open circle. So I just drew an open circle next to 4 to remind me that 4 is not actually on this line, but let's plug it in anyway. Negative 2 times 4 is negative 8. Negative 8 plus 6 is negative 2. Negative 2 times 5 is negative 10. Negative 10 plus 6 is negative 4. Negative 12 plus 6 is negative 6. So plot those points, but be careful because at 4, negative 2, we need to have an open circle. And we draw in that piece. Now notice that on the vertical line x equals 4, you can only use this pinkish purple line for 4. You can't use the green line for 4 because there's an open circle at the green line, but a closed circle on the purple line. So this still covers all possible x values, but it just says that if you are negative 5, 0, all the way up to 4, you're on the purple line. If you are anything larger than 4, you're on the green line. Okay, do you guys know why in the world piecewise functions exist? Okay, think about worlds of fun. A child, I don't even know, 2 and under, might be $12 to get in. How much does it cost for you guys to get into worlds of fun? Like 26? Something like that? A little more than that? Okay, so I'm living in the past. Let's say it's $26 for you all to get into an amusement park. If somebody is ages 65 or older, they get a discount. It only costs them, I don't know, 20 bucks to get into the park. So that could be represented with a step function. If you are 2 years old, you pay this amount. If you are 15 years old, you pay this other amount. And if you actually wanted to look at that on a graph, it would look like one of these step functions. So let's go down here to the step function. What I want you to notice about the step function is the domain restrictions. 0 is less than or equal to x is less than 3. Because it's less than or equal to on the first part, that'd be a closed circle, and then an open circle on the other number. Basically, a step function is a whole bunch of horizontal lines, but it's little pieces of it. So our first one is the horizontal line y equals 1. So where would be the horizontal line y equals 1? Oh, first of all, on this one, just to help you out, we are going to change so our origin is over here. That will make everything fit on this graph. So y equals 1. This first equation is the horizontal line y equals 1. But it has to be for the values, the x values 0 through 3. Let me zoom in a little bit so you can see this even better. The next one is going to be the horizontal line y equals 2 between 3 and 6. So the horizontal line 2 between 3 and 6, we are including 3, we are not including 6. Hopefully my projector will catch up here in a minute. The next equation is y equals 3. This is between 6 and 9. So the horizontal line y equals 3, which is going to be here, but only between the x values of 6 and 9. Closed circle at 6, open circle at 9, and connect them. Okay, this last one that I'm going to do in red is the horizontal line y equals 4. Can you guys figure out how to put that on the graph? Is this making more sense today than it was yesterday? Okay, that's, as long as you feel slightly better today than you did yesterday, I feel like we're getting somewhere. So a horizontal line at 4 between 9 and 12, closed circle at 9 because it has the equals line, open circle at 12, and connect them. This could indicate, let's say there's some parent raffle ticket thing, and you can enter based on how many kids you have. If your child is newborn up to, but not yet turning 3, it's $1 per raffle ticket. If your kid has turned 3 up to just under 6 years old, it's $2 for a raffle ticket. If your kid, why does it jump like that? If your kid is between 6 and 9, it's $3 for a raffle ticket. If your kid's between 9 and 12, it's $4 for a raffle ticket. That would be a real world situation for this kind of step function. So if you haven't already, try number 8 on your own. The one thing I want to point out to you, how are the open and closed dots going to look? Notice the first one is less than, so that's going to be open dot. And the second one is less than or equal to, so closed dot. So your step function for number 8 is going to be open dot on the left, closed dot on the right. Okay, so this particular step function is a collection of 4 horizontal lines. Y equals -1, y equals -3, y equals -5, and y equals -7. And I just wrote this out using words. Instead of -5 is less than x is less than or equal to 2, I wrote between -5 and -2. So there's a horizontal line, y equals -1, between the x values of -5 and -2. So there's that piece of the graph. The next one is the line y equals -3, but only between the x values of -2 to +1. The next one is only between 1 and 4, and the next one is only between 4 and 6. So it's just seeing each little piece of that graph based upon the x values.